Good morning or good afternoon. Today we're going to be writing notes on solving special systems of equations. So solving special systems of linear equations. I always forget to say linear when I talk about systems of equations. And I want to say that this is page 16, but I'll put a question mark because it could be different in your notebook. You can put whatever page number you want. And this is chapter 5, section 4, so 5.4 in your book. As always, we are going to write our essential question. So the question is, can a system of linear equations have no solution or have many solutions? We're going to figure that out. I think if you were paying attention to our Desmos activities over the last couple days, we discovered the answer to that question. So you could probably already answer that question just based on the evidence of our Desmos activities. So let me give you an example. We're going to compare a very small real-world scenario. So let's say that your cousin is 3 years older than you. You can represent your ages with linear equations, guys. So we're going to say that y, or how old you are, is in terms of the time. Y equals t. And we're going to say that your cousin's equation or your cousin's age is your age, which is t, plus 3. Because she's 3 or he's 3 years older than you. This is your age. This equation represents your age. And this represents your cousin's age. Okay, now we can graph the linear equations. And I'm going to make a graph of just the first quadrant. Remember yesterday we reviewed the coordinate plane? I'm just going to draw the first quadrant where all the values are positive because you can't have a negative age anyways, so. We're going to say that this axis, instead of it being the y-axis right now, we're going to call this the t-axis for time. And then the y will be like your total age. Okay. So in red, I'm going to write your age. I'm going to draw the graph of your age, y equals t. So pretend that y is equal to x. So if y were to be equal to x, like if we had our x-axis, right now the only difference is that we change the letter and we can do that. The slope is the number that's in front of x, and the y-intercept is anything that's being added or subtracted. So is anything being added or subtracted to the x, or to your t in this case? So is there anything that's being added or subtracted? Is there anything that's being added or subtracted? Tell me in the chat. All right, guys, so our slope is 1 over 1 because when there's nothing in front of the x, we know that it has a coefficient of 1 because there's 1x. And there's nothing being added or subtracted, so that means my slope is 1 over 1. And my y-intercept is 0, 0 for the first one, for the first question. Remember I told you that we can replace t with x, but let's put t back. Because our x-axis is now our t value. Oh my goodness, it's not wanting to erase the x, so I'm just going to write a t over it. Okay, So my y-intercept is 0, 0. I'm trying to graph y equals t. You can graph y equals t when you have y-axis and a t-axis. So 0, 0 is right here. That's my y-intercept. I'm going to plot it in green. And my slope is go up 1, right 1. So up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Do you guys see a pattern? Yes. Now connect all of those. Now the green line represents your age. That's how old you are. And now your cousin's age, we're going to do in yellow. Our slope is 1 over 1, because that's the number that's in front of, that's the coefficient of t. And our y-intercept is 0, 3. So I'm going to start at 0, 3. And same thing, I'm going to rise 1, right 1. Rise 1, right 1. So what do you notice about these lines? Are you and your cousin ever going to be the same age at the same time? Ever? No. So that means that these lines are parallel. So is there a solution? Is there a point in time when you're going to be the same age at the same time as your cousin? No, that's impossible. I mean, realistically speaking, in the real world, that's impossible. And mathematically speaking, that's also impossible. Y equals t and y equals t plus 3 are never going to intersect. So there is no solution. Because I'm just going to say my cousin and I, and you can write it like that too. My cousin and I will never be the same age at the same time. So if you guys remember from our Desmos activity, we actually arrived at some conclusions. And hopefully some of you guys remember. So we found the different types of solutions to the systems of linear equation. And I'm going to abbreviate this. So system of linear equations. Because I don't want to write it again. This is a y right here, by the way. So let's say we have a graph that looks like let's write our x and y axis 3 times. So let's draw it 3 times. Okay. Cool. So if we have intersecting lines like this and like this, what type of solution is this when we have a intersection of 2 lines? How many solutions does this graph have? You can tell me in the chat. How many solutions does this graph have? Thank you to those of you who told me in the chat. Yep, there's only 1 solution. And it's the point at which the lines intersect, right there. And we would express that as a point, x comma y. That's where the lines intersect. Now, we just learned about this scenario. We also saw it in our Desmos activities. If you have a pair of parallel lines, how many solutions are in that when you have a pair of parallel lines? Correct. There's actually no solution because those lines never intersect. This is when the lines are parallel. Do you guys remember when we were doing Desmos? There was another way we could figure out if lines were parallel. I told you guys algebraically how you could find if lines are parallel. Remember I told you the slopes, if their slope was the same? You remember? So like example, you had something like y equals 3x and y equals 3x plus 1. Those have the same exact slope. Those are going to be parallel lines. And then the last example is when we just have like a line on top of another line, or when you're just given one line. This was my favorite solution. It's infinitely many solutions. Infinitely many solutions when the lines are the same. So there's, oops, let's just undo that. There we go. So there's one solution, no solution, infinitely many solutions. And this is when the lines are the same. So now we're going to get into the actual like 8th grade level stuff right now. What we've been doing is 8th grade level stuff for those of us that are in this accelerated course. But there are actually 3 different ways to solve a system of equation. So there's 3 ways to solve a system of linear equations. There's 3 ways. Okay, we've learned about graphing. I think graphing is our favorite and probably the quote-unquote easiest because we have software like Desmos. So if we were going to graph something like a system of equations like y equals 3x plus 1 and y equals 3x minus 3. If a system of equations is being listed, it's probably going to have this, like a system. It's a little squiggly line. It's like a giant parentheses, pretty much, saying this is a system of equations. What is the solution? So I'm going to quickly draw my x and y plane because I don't need Desmos and neither should you. These graphs, these lines are in y equals mx plus b form. So we can graph them pretty quickly. So in the first question, what's my y-intercept? Look at your first linear equation. What's my y-intercept? Tell me in the chat, what's my y-intercept in this equation, this first equation? Tell me in the chat. Yes, it's 0, 1. That's my y-intercept. Now what's my slope in my first equation? What's my slope? Yes, thank you. 3/1 is my slope. So let's go and graph 0, 1, which is right here. Our slope is rise 3, right 3. So rise 3, 1, 2, 3, right 1. All right, there's my first line. Cool. See how I don't need Desmos? Because these lines are in y equals mx plus b form. So now I'm looking at my second equation. What's my y-intercept in my second equation? What is my y-intercept? Zero comma negative 3. 0 comma negative 3 is down here. And now my slope is rise 3, right 1. Rise 3, right 1. Rise 3, 1, 2, 3, right 1. Rise 3, 1, 2, 3, right 1. What do you guys notice about these lines? Do they have a solution? Nope. No solution because the lines are parallel. Do you guys know another way that you can prove that these lines are parallel? Just by looking at the linear equations? Look at the linear equations. Do you notice something about the linear equations? What's similar about the linear equations that can lead us to conclude that the lines are parallel? They have the same slope. They both have a slope of 3 over 1. So we could have from the beginning said that there's no solution because both have a slope of 3. All right, so that's graphing. That's solving a system of equations using graphing method or the graphing method. The other way is to use substitution. We can substitute one equation into the other equation. So let's say we have the same system of linear equations. Y equals 3x plus 1 and y equals 3x minus 3. We already know it doesn't have a solution. But instead of graphing, instead of looking at their slope, we're going to try substituting one equation into the other equation. So let's substitute equation 1 into equation 2. Let's try substituting the first equation into the second equation. So if you notice here, y equals 3x plus 1, right? And then we also say that y equals 3x minus 3. So do you see how they both have y right here? We can substitute this right here. We can just plug it in and make an algebraic, like we can make a two-step equation or a multi-step equation. So now when I substitute, I have 3x plus 1 equals 3x minus 3. I just plugged in 3x plus 1 into my y, into the second equation. Now I can solve. So let's try to solve for this. Let's I don't know, like let's subtract 1 from both sides. This zeroes out. You're left with 3x equals 3x. Negative 3 plus negative 1 is negative 4. Sorry guys, I'm going to move this up now. So if we subtract both sides by 1, we end up getting 3x equals 3x minus 4. Now I'm going to move the smallest variable, so I'm going to move the 3x. But when I move the 3x, cancels on the right, and I'm left with negative 4. But on the left, 3x minus 3x is 0. Does 0 equal negative 4? Nope. So this means that it's no solution. And we proved it algebraically by using substitution. Now, the last way that you can solve for a system of equations is by using the elimination method. That's the last way that you can solve a system of equations. So let's write the system of equations one more time. Y equals 3x plus 1. Y equals 3x minus 3. And we are going to take equation 1 and equation 2, And we're going to observe if there's anything that we can cancel from there. Like if we were to actually get like y equals 3x plus 1 and add it to y equals 3x minus 3. I just rewrote them. Now, if I were to add them together, nothing eliminates. Nothing eliminates. But if I multiply the first equation by -1, I'll be able to eliminate something after. So let's multiply. -1 times y, that's negative y. -1 times 3x equals negative 3x. -1 times 1 is -1. Okay, so now that I have this version, of equation 1, I can bring equation 2 over, unchanged, and I can see if anything eliminates now when I add them together. So when I add them together, negative y plus y is 0. Negative 3x minus 3x is 0. -1 plus -3 is -4. So again, I have 0 equals -4. Does 0 equal -4? No. So we just found that there's no solution using the elimination method, using substitution, and sorry guys, for some reason my thing won't let me zoom out, but we learned that we have no solution by graphing, by substitution, and by elimination. These are the 3 ways that you can solve a system of linear equations. And the bigger picture is that you can have one solution, no solution, or infinitely many solutions.